Yeah, coming back to the lecture. In last lecture, we have seen about permanent magnet moving coil instrument and your moving ion instruments and its advantages, disadvantages, applications, etc. And in this today's lecture, we are going to see about three-phase power measurement, and this is one of the important topic in your unit. So this three-phase power measurement, how we are going to measure a three-phase power. So it is done by some four methods. One by using a three single-phase wattmeter. That is, all phases are connected with a single-phase wattmeter. So it is also termed as 3-wattmeter method. And by using two single-phase wattmeter, that is, two phases of your supply is connected to 2 wattmeters. That is termed as 2-wattmeter method. And by using 1 wattmeter, one single phase wattmeter, it is termed as 1 wattmeter method, or by using a 3-phase wattmeter, a single 3-phase wattmeter is connected to the system in order to measure this your 3-phase power. So these are the four methods for the measurement of 3-phase power. So among this, the most commonly used 3-phase power measurement technique are your 2-wattmeter method and 3-wattmeter method. 3-phase wattmeter method based upon the advantages of those wattmeters. And coming to a 3-wattmeter method, that is, there will be 3 wattmeters in your all 3 phases. So it has 3 wattmeter as shown in the figure. The figure will be shown in the next slide. So it has 3 current coils and 3 pressure coils. So the bigger coil is termed as current coil. The bigger coil in the wattmeter is termed as current coil, and this more number of turn coil is termed as pressure coil. So there will be 3 current coils as well as 3 pressure coils. So these coils are termed as elements of your wattmeter. So this 3 wattmeter method is also termed as 3-element wattmeter. So the question is, in university you may asked to write the question can be asked as explain 3-element wattmeter. So 3-element wattmeter is nothing but 3-wattmeter method, and the voltage across the pressure coil of wattmeter is your phase voltage across the load. From this only we can find the value of voltage. So this voltage across the pressure coil, the voltage across this pressure coil will be equal to the phase voltage that is across the load. So from the diagram you can even clearly understand this thing. And the voltage across pressure coil in wattmeter 1 is VR. That is, this VR is nothing but your voltage across R phase. And similarly, voltage across pressure coil of the wattmeter 2 is Vy. And similarly, for wattmeter 3 it is Vb. So Vy, Vb, Vr is nothing but voltage across R phase, Y phase and V phase respectively. And here's the diagram of your 3-wattmeter method. This is wattmeter 1, W1, W2, W3, wattmeter 1, wattmeter 2, wattmeter 3. And this is the load connected to the your supply. So R phase, Y phase and V phase, all 3 phases are connected with the your wattmeter. That is why it is on. This is what the current coil 1, 2, 3. So there are 3 current coils and pressure coils 1, 2, 3, 4. So 3 pressure coils. That is why it is termed as a 3-element wattmeter. And the voltage across the phase will be equal to the voltage which is developed in the pressure coil. So here this is how your voltage is being developed, and it is given by VR, Vy and Vb respectively. So this shows the diagram of your 3-wattmeter method. And so if the current passing through all the phases is IR, IY and IB. So instantaneous power is nothing but product of your voltage and current. We all know that. So VR into IR plus Vy into IY plus Vb into IB. So this will be the total instantaneous power that is consumed by load. So it has also been denoted as total power P is equals to VR IR is equals to PR, Py IY is equals to Py, Vb IB is equals to Pb. So sum of this will give the instantaneous power. So by this way you can measure the value of power, 3-phase power, that is R phase, Y phase and V phase. By sum of all these values of your 3-phase power will give the total power. This is how we are measuring the 3-phase power with the help of 3-wattmeter method. And the next method is 2-wattmeter method. We are going to use only 2 wattmeters. So this method is also called as 2-element method, as there is only 2 pressure coils and 2 wattmeters. And In this method, the common points of pressure coil is connected to third phase without wattmeter. So the pressure coil common point is connected to third phase of your wattmeter. This is the point. So this is the common points of your pressure coil. It is connected to the third phase of your wattmeter. And there are two cases of two wattmeter method. One is star connected load and delta connected load. Based upon the type of load connected, it can be, there will be two cases of your two wattmeter method. One is star connected load and other one is delta connected load. The star connection is also called as Y connection or Y connection. And your current through current in the wattmeter is given by instantaneous current flowing through R phase, Y phase, B phase or nothing but IR, IY, IB, and instantaneous voltage across R, Y, B phases or VR, VY and VB respectively. And this is the diagram. There are only two wattmeters. This is wattmeter 1 and this is wattmeter 2. And this is power of wattmeter 1 and this is power of wattmeter 2. So P1 plus P2. And the process is going to be similar as that of your three-phase wattmeter. You are going to add the values. How the value becomes the total power we can see now. So instantaneous reading of the W1 is nothing but your P1. So it is nothing but your IR, current through phase R, into VR minus VB. From the diagram you can understand clearly. So the power P1 is nothing but your current IR into your voltage at your R phase as well as V phase. That is VR minus VB. That is what it is being shown here. And similarly, power at wattmeter 2 is IY into VY minus VB. Why? Because this voltage is sharing between these two elements. That is why we are subtracting the value of voltage. And current is IY and voltage at VY as well as voltage at VB. So VY minus VB. This gives this equation. So sum of instantaneous power will give the total power of three-phase total three-phase power. So P1 plus P2 is equals to IR. We are going to add these two values, IR into VR minus VB plus IY into VY minus VB. So multiplying this value, we get IR into VR minus IR into VB plus IY into VY minus IY into VB. So this can be rewritten as VR IR plus VY IY minus, we are taking the VB term constant, IR plus IY. So as the load is connected, is star connected by using KVL, we can understand that if you apply KVL in the system, you will be clear that sum of all the current are entering the node. So this entering current, sum of current entering is equals to sum of current leaving. So there is no leaving current. So IR plus IB plus IY is equals to 0. That is why it is termed there. IR plus IY plus IB is equals to 0. So this says that IR plus IY is equals to minus IB. So instead of IR plus IY, we are going to substitute minus IB here. So your equation will become, substituting equation 4 and equation 3, your equation will become VR plus IR plus VR into IR plus VY into IY plus VB into IB. So this gives the total power consumed by the load. This is applicable for both balanced as well as unbalanced load. And coming to delta connection, the instantaneous power is given by, so in delta connection the diagram is here. The voltage across this R and B phases VBR, VRY, VYB respectively. So this is how your voltage will be. So I was writing the formula for your wattmeter 1 power, that is P1 is equals to minus VBR. Why minus? Because we are measuring the term with respect to R phase. We are measuring the term with respect to R phase because of the current IR. But the voltage is from B to R. So we are giving minus sign in this equation. So your power P1 is equals to minus VBR into IRY minus IBR. Here current is the difference sharing, we are sharing the current. So IRY minus IBR will be there in equation 6. So instantaneous reading of wattmeter 2 is equals to P2. Power 2 is equal to VYB into IYB minus IRY. Here there is no negative sign. Why? Because it is drawn with respect to the your Y phase current. That is why VYB has no negative sign. So adding these two powers, we get by solving this, we are going to add these two equations, and we are solving this equation. Finally, we get VBR plus IBR plus VYB into IYB minus IRY into VYB plus VBR. So now we are going to use Kirchhoff's KVL voltage law. So voltage law is sum of potential rise is equals to sum of potential fall. We have only potential rise here. So potential rises are voltages of all the phases. VRY plus VYB plus VBR will be equal to 0. So from this equation we can understand that VYB plus VBR is equals to minus VRY. So the equation, your equation 8 will become P1 plus P2. Instead of your VYB plus VBR, we are substituting minus VRY. Multiplying these values, so minus sign will get cancelled. So finally, P1 plus P2 is equals to VBR, IBR plus VYB, IYB plus VRY, IRY. So this is nothing but the total power consumed by the load. So this gives the three-phase power. So with the help of 2 wattmeter method, this is how we obtain the three-phase power. So P1 plus P2 is equals to total power consumed, and this is also applicable for both balanced as well as unbalanced load. Coming to three-phase wattmeter, it is similar to that of your 2 wattmeter method, and here is the diagram of your three-phase wattmeter method. So here here one resistance is being connected. This resistance is used to avoid error in three-phase power. What we are going to measure, and this resistance, this method of connecting resistance is termed as Waystone method, and this might look similar to that of your 2 wattmeter method, and but the common point is not connected. Common point of your pressure coil is not connected to the third phase. That is the only difference between 2 wattmeter method and 3-phase wattmeter method. And here ends otherwise your power consumed will be similar as that of your 3-phase wattmeter method. And coming to the next topic is your instrument transformer.